All right, let's jump right into today's critical security explainer. We're going to be putting on our intelligence analyst hats today to uncover a hidden endpoint data risk that is quite literally hiding right behind the trusted shield of encryption. You know, as executives and security leaders, we often hear the word encrypted and just treat it like a blanket guarantee of safety. But recent research has exposed a massive blind spot in how major applications, specifically WhatsApp on Apple devices, handle local data storage. We're going to look at the gap between data in transit and data at rest, and why your corporate communications might actually be way more exposed than your IT policies suggest. So, here's our intelligence briefing for today. First, we'll shatter the encryption illusion. Second, we'll define the shared container flaw. Third, we're going to map out the real-world business risks. And finally, we'll equip you with actionable enterprise mitigations. Let's get to it. Starting things off with Section 1, the encryption illusion. Okay, consider this startling discovery from the iOS security researchers over at Musk. They recently revealed that despite the incredibly strong protections your data enjoys while traveling across the internet, WhatsApp chat histories are actually landing unencrypted right on our Apple devices. I mean, think about that for a second. We spend vast resources securing the perimeter and the network transmission, but the moment the data arrives safely at its destination, it's basically unpacked and left sitting totally out in the open. And this really hits the nail on the head regarding the core issue we're facing. On one side, we have end-to-end encryption, or E2EE. This is the impenetrable fortress protecting our messages securely during transmission between users, and honestly, it's fantastic technology. But on the other side, we have local storage security. And the absolutely crucial takeaway here is that local storage depends purely on how the app is implemented, not on that robust E2EE. It's kind of like having a state-of-the-art armored car deliver your cash, but the second it arrives at the bank, they just leave the vault door wide open. Let's move along to our next section and see how this builds into an architectural vulnerability. Section 2, the shared container flaw. To really understand this exposure, we have to talk about the shared app container. Now, Apple operates on a sandboxing model, which normally isolates apps from one another to keep things secure. Pretty standard, right? Well, a shared app container is a designated shared local storage folder designed specifically to allow data exchange between different apps created by the exact same developer. It doesn't violate Apple's sandboxing rules. Rather, it creates this larger shared sandbox where an app like WhatsApp can drop its data, so another app from the same developer family can potentially access it. So here is where it gets sketchy. Inside that shared container, the chat database, which is commonly named Axolotl Squad, is sitting in plain text. Plain text, meaning it is completely unencrypted at rest. It is totally readable to anything that has permission to look inside that shared folder. All those confidential client conversations, internal strategic discussions, sensitive attachments, stuff that was so carefully encrypted in transit is simply resting as standard, readable text on the device. Now let's look at the actual scope of this exposure, because there's a bit of an important debate to highlight here. Musk researchers claim that because of this shared container, all Meta-owned apps on an iPhone, like Facebook or Instagram, can theoretically read these WhatsApp chats in plain text without requiring explicit user consent. However, to keep things completely objective, we gotta note the community context surrounding this claim. Other analysts argue that only WhatsApp Messenger and WhatsApp Business have access to the specific shared container, primarily to allow things like chat history migration. But look, what you really need to take away from this, the absolute bottom line for your enterprise, is that the architectural design fundamentally relies on data isolation that is porous by design. It intentionally allows cross-app access. So what does this all mean for us? Let's translate these technical mechanics into real-world business risks. Section 3, real-world business risks. Let's map out exactly what this means for your threat model. These unencrypted databases introduce several vectors for data compromise. First up, cross-app access. This means potential data leakage within that same developer ecosystem, just like we discussed. Second, there's a heightened risk of malicious apps finding some way to exploit those shared container permissions. Third, and this is a massive one for IT teams, forensic extraction. If an endpoint is compromised or jailbroken, that plaintext database is incredibly easy pickings. And this is especially pronounced on macOS systems where file system access is just way more flexible. If your macOS endpoints are weak, a bad actor can extract that chat history with minimal effort. And finally, insider threats, the misuse of legitimate app privileges to quietly access that plaintext data. Now, this next point is absolutely crucial because it breaks a very dangerous assumption. I hear executives say this all the time, but Apple encrypts the phone. Yes, Apple's data protection framework does encrypt files based on the device state, meaning when the device is actually locked. but that does not guarantee application-level databases are isolated from authorized apps. Once that phone is unlocked by the user, that device-level encryption steps aside, and authorized apps within that shared container can read the plaintext data without restriction. Device encryption is simply not a substitute for application-level data security.
With the threat clearly defined, let's move to the most important part of our briefing. Section 4, Securing Your Enterprise.
Organizations absolutely must take active precautions. Relying on end-to-end encryption is just no longer enough when decrypted data is residing safely on your endpoints. So here's your action plan based on the research. Step 1, deploy mobile device management, or MDM solutions, to strictly restrict app permissions across your enterprise environment. Step 2, enforce strong passcodes and biometric locks on all fleet devices to maximize Apple's baseline data protection framework. Step 3, audit and limit unnecessary apps from the same developer ecosystem. For instance, if you use WhatsApp for Business, maybe your employees shouldn't be installing personal social media apps from the exact same developer on that corporate device. And finally, step 4, if you operate in a high-security use case, consider alternative messaging apps that actually feature stricter, locally encrypted storage models. This brings us to a critical realization about the broader industry challenge of securing data at rest. As we place so much emphasis on encryption in transit, the target for attackers inevitably shifts directly to the endpoint, right where that data is finally decrypted and stored. So I'm going to leave you with this final thought to evaluate your current security posture. If your encrypted data is literally sitting in plain text at the endpoint, how secure is your enterprise, really? Thank you for joining this explainer. I really hope this helps you tighten your defenses and stay secure out there.